Hey everyone, this is the next chapter on areas. So the name of this chapter is areas related to circle. We have already done this chapter on surface areas and volume. So this chapter will be fairly very easy for you. For the first exercise of this chapter, you only have to know two formulas. One is area of a circle. Area of a circle whose radius is given is pi r square. Then we have perimeter, also called circumference, which is 2 pi r, or you can write it as this 2 times r. What is 2 times r? It is diameter, no? Or you can write perimeter as pi d. Okay, 2 pi r or pi d. So these are the two formulas we would need to start with our exercise number 1. So here's the first question. Let's look at it. It says the radii of two circles are 19 centimeter and 9 centimeter respectively. So in areas related to circles, we are mostly dealing with plane figures. There is no three-dimensional figures because we are not interested in the volume of anything. We are only interested in the area, so mostly plane figures. Okay, the radii of two circles are 19 and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of circumference of the two circles. Okay, so we have two circles here, one with radius 9 centimeter and the other with a radius of, or I don't know where you can see, so that is 19 centimeter. So you have to find out the radius of that circle whose circumference is the sum of circumference of these two circles. Okay, so that is a third circle. I don't know, you don't actually need figure for this kind of questions, but still, let's say this has a radius. This has a circumference that is similar to the sum, that is same as the sum of circumference of the two circles, the other two circles. Okay, this is circle A, this is circle B. Okay, so let's write solution. I'll put this as C. Okay, yeah. For circle A, radius A is equal to how much? 9 centimeter. So the circumference, that is, let's say perimeter of A, is 2 pi r, that is 2 pi into 9, or that is 18 pi centimeter. Perimeter is the length, so its unit will be centimeter, not centimeter square. Then we have circle B, whose radius is given as 19 centimeter. So perimeter of the second circle will be 2 pi into 19, which is 38 pi. That much centimeter. So we have the perimeter of the first circle. You have the perimeter of second circle. Now the third circle has a circumference. See, find the radius of the circle which has circumference equal to sum of circumference of the two circles, which means the perimeter of C is equal to perimeter of A plus perimeter of B. Okay, very clearly written in the question. You have to find the radius of that circle which has a circumference equal to sum of circumference of the two circles. Okay, the circumference of two circles is 18 and 38 pi. Okay, so now let's say this circumference will be 2 pi into RC, correct, no? Let's say for circle C, circle A, circle B, for circle C, radius C I don't know, perimeter of C I know, right? That will be 2 pi into RC. Okay, that's what I've written here. So for circle C, it is 2 pi into RC, which is equal to 18 pi plus 38 pi. Okay, so you can have simply written it as 2 pi itself. Okay, so I'll write 2 pi into 9. Okay, I don't want to, I'll write what is here, what is written here. So 2 pi into 9 plus 2 pi into 19. Okay, so if you observe, you see the 2 pi cancels out and you have RC is equal to 9 plus 19, which is 28 centimeter. So the radius of this new circle will be 28 centimeter. Very, very basic question. Okay. So this is just giving you an introduction on how the questions will be on this chapter. So please note it down. Let's go to question number 2. Okay. So here is question number 2 of the exercise, which says the radii of two circles are 8 centimeter and 6 centimeter respectively. Find the radius of the circle having area equal to sum of the area of the two circles. The same question like what we did before. There it said the third circle had the perimeter that is equal to the sum of perimeter of the other two circles. Here it is area. So we have two circles. I'm not going to solve this question for you, but I'll just give you an idea. This is the radius. First radius is given as 8 centimeter, and then there is another circle which has a radius of 6 centimeter. Okay, so this is A, this is B, and this is C. Okay, this is C. Let's say RC. C. Okay, it says here we have circle A. Solution. Circle A has radius A as 8 centimeter. So what will be the area? It is pi RA square. For circle B, the radius is RB. How much is given? 6 centimeter. So this will be pi into 8 square, that much centimeter square. Here this will be pi RB square, that is pi into 6 square, that much centimeter square. And you have circle C, which has radius as, I don't know, you have to find out, but the area will be pi RC square. It says, the question says area of C equal to area of A plus the area of B. Substitute the values just like before. Substitute all the values, cancel out terms if you have anything to cancel. Then finally, you can get the answer for RC is equal to this much centimeter. Okay. So this I'm not going to solve it for you, but you got the idea of how to solve it. Please move forward, solve this question. Let's look at question number 3. Here is question number 3. The figure depicts an archery target marked with its 5 scoring regions from the center outwards as gold, red, blue, black and white. The diameter of the region representing the gold score is 21 and each of the other bands is 10.5 centimeter wide. Find the area of each of the 5 scoring regions. This is the question. So let's say they have given the diameter of the gold region as 21. The diameter is given as 21 of this gold region. I'm not marking the diameter. So if diameter is 21, then the radius, this much portion, that will be 21 by 2. Right now, they're also telling me that this width here, this width is also, the width is given as how much? It's given as 10.5. So 10.5, can I write it as 21 by 2? Half of 21 is 10.5. Okay. So this is also 21.5. So if this is 21.5, let's say this is RG, that is R of gold, then what will be R of red, the whole region? That will be 21 by 2 plus 21 by 2. It will be 21. Again, you have the next radius here from the center. That will be 21 plus 21 by 2. That will be 63 by 2, etc. Like that, you can find radius of the first RG, RR. You can find RG, you can find RR, then you can find RB. Okay, so these are the radiuses of individual regions. Now the question is, find the area of each of the 5 scoring regions. Let's start with gold. Let's start with gold. What is the shape of gold region? It's a circular region, no? Gold is a circular region on the inside with RG as 21 by 2. Okay, so R of gold, our radius of gold is 21 by 2 centimeter. So its area can be easily calculated. That will be pi RG square, that is 21 by 2, sorry, 22 by 7 into 21 by 2 into 21 by 2. So you cancel and you get an answer for gold. That's the gold region. Now tell me, we have to find the red region. That is, if this is gold, the next region is red. Okay, the next region here is red. I only have to find out the red region, not the red circle. See, this is red, and this is the radius, or let's say this total is the radius of red, RR and RG. Okay, so if this is a total red circle, this is a total red circle, I only need the red region. That is, I only need the area of this particular region. So how do I find out? You find out the total area of the red circle as a whole. You find the red circle as a whole. From that, you can simply subtract this gold circle. If you subtract the gold circle from here, then the highlighted area, that is your red region. Okay. So for red region, let's write area of red region equal to area of red circle minus area of gold. Can I do that? The whole circle minus the gold area. This is gold. I subtracted the gold, which I have already calculated. You get a value here, this much centimeter square. That is the value of gold. Now you have to find the area of the red region. For that, the total area of red circle minus the gold circle, that will also give you some answer. So this will be pi RR square minus pi RG square, or pi comes as common, you can get RR square minus RG square. RR is how much? It's 21. Okay, with that you can find the gold region. Now how to find the blue region? Let's say this is gold, this is red, and let's draw the gold one. Gold is done, red is done, now blue. When the blue has to be calculated, this is gold, this is red, now this is blue. Okay, this total is blue. So this if I find out, that is the total area of the blue circle. Okay, area of blue region, not circle, blue region equal to blue circle minus, see the gold, I know I don't need to mind, but can I subtract the whole circle of red? There are two ways of doing it. Either you can find the total area of this blue circle, then subtract red region and gold circle, or you can find out the total area of the blue and subtract this red circle as a whole. The total circle you can delete, the whole circle you can delete. See, the whole circle you can delete. You can say that this is the total is red. Don't mind the gold, it's already included. So the total blue circle minus the red circle will give you blue region. So blue circle minus red circle. So your answer will be pi RB square minus RR square. Okay, like that you can proceed with black and white and find the answers for all the separate regions. And with that, your question number 3 is finished. Okay, understood? So with that, we'll move to question number 4. Yeah, we finished question number 3. Here is question number 4, which says, wheels of a car are of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of 66 km per hour? Okay, it may sound like a difficult question, but just apply your brain, you can easily get the answer. Look at this. This is a wheel, and the diameter is how much? It is 80, so the radius will be 40. No problem. So in one revolution, let's say here is a point. In one revolution, this wheel is rotating and it reaches this point. Okay. Then when it travels this much distance, It's just like opening up this circle. Okay, in one revolution, when this point reaches here, the total distance traveled will be equal to circumference of the circle, right? Now, when you have this point here, let's say this is the point, this is rotating from this point to this point. Okay, since this is in contact with the ground, this will move forward. Okay, so when it travels this much distance, it is traveling the distance equal to the circumference, no? Same as circumference. So distance traveled by distance covered by the wheel in one revolution. When it rotates once, how much will it be? Equal to perimeter, which is equal to 2 pi r. Okay, that is how much distance this wheel will cover when it rotates for one single time. So in one revolution, not rotate, for revolving, yeah, whatever, for revolving, for one revolution it covers 2 pi r distance. Okay, that's the perimeter. My question is, how many such complete revolution does the wheel make in 10 minutes when the car is traveling at a speed of 66 km/h? So I have to find out how many revolutions. So let's say 2 pi r, let there be n revolutions. Okay, I'll write let there be n revolutions. Okay, we're slowly starting to apply our brain here. Let there be n revolutions. Okay, if there is one revolution, the distance traveled by the wheel is 2 pi r. What if there are 2 revolutions? 2 pi r into 2. What if there is 3 revolution? The total distance covered is 2 pi r into 3. Here there are n revolutions. So total distance covered is 2 pi r into n. Okay, now we have to find out the total distance covered. You have to find out distance covered. So how will you find the distance covered? How to find the distance? And a very simple thing. See, the speed is given, time is given, distance is equal to speed into time. Everybody knows. Okay, what is speed given? 66 km/h. 66 km/h. Let's convert this into meter per minute. So 66 into 1000 by 60 minutes. Okay, 0 cancels, this cancels, so 1100. So that is 1100 meters, almost 1.1 kilometer. That is in 1 minute. Okay, this much meter per minute. My question is to find out time is 10 minutes. In my question, time is given as 10 minutes. So distance is equal to speed 1100 meter per minute into 10 minute. Okay, this minute cancels. You will have 11,000 meter. That is the total distance covered by the car in 10 minutes, because the speed is given, time is given, so you can easily find out the distance traveled by the car, no? Okay, so this is the distance traveled by one wheel in one revolution. This will be equal to this, so you can say 11,000. I'm guessing that I did not make any mistakes here. Is equal to 2 pi r into n. Okay, so substitute values, you get 1000. 2 into 22 by 7 into 40 into n. Okay, so 22 into 5 is 110, 500, 4 cancels. Then solve and find out if it is coming in points, then you can round off to the nearest value and you can find the number of revolutions by, oh, they're asking for how many complete revolutions they are asking. So if you are getting the answers in points, let's say you are getting some answer x.3, then this 0.3 is not a complete revolution. So you can eliminate this point part and this will be your answer. Okay, got it? Is it clear? See, this is the total distance traveled by the wheel in one revolution. You also have to find out the overall distance traveled by the car in 10 minutes. when it's moving at a speed of 66 km per hour. Speed is given, time is given. I can easily find out the distance traveled by the car, and I know the distance traveled by the wheel in one revolution. Then total revolutions will be equal to, total distance in this covered by this wheel will be equal to total distance covered by the car. You're equating both the things, you will easily get the value for n. Alright, question number 5 is very simple question. You just have to equate things, apply your brain, get the answer. With that, exercise number 1 is finished. I'll see you all in the next video.